Hey everybody, and welcome back to another fun and exciting intermediate math class. Today we're going to be starting off chapter number 3 in your book that is on page 98. So if you will go ahead and look at page 98 with me, we're going to be actually talking about algebra in this chapter. Yay! And some of you are like, oh, okay. So some of you have been looking forward to algebra. Maybe you've heard good things about algebra, and some of you are like, oh no, this is going to be terrible. And you've heard bad things about algebra. Well, hopefully, if we learn it right, it won't be that challenging for you, and you can do well and you can have great success. So let's go ahead and start off there. You can look down at page number 98. We will be talking about today what's called the properties of algebra, or the properties of arithmetic. These are properties that you should already be familiar with, but now we're going to start using them more because in algebra we use them a lot. So let's talk about them. There are 3 different properties that we'll talk about in this lesson. So let's talk about number 1, the commutative property. The commutative property. In the commutative property, in addition and multiplication, the numbers can be switched without changing the answers. Notice it says that subtraction and division are not commutative. So check this out. Again, like I said, you've been doing this. You know what you're doing here. You just maybe have never heard it called this. So watch this. If I have 4 plus 3, 4 plus 3 equals 7. I could also have 3 plus 4, and that also equals 7. Notice that I switched the numbers, right? But I did not change the answer. It stayed the same. Now, it says that you can do that with multiplication. So if you look, addition, you can do that, and multiplication. So let's try it. So if I have 3 times 4, that equals 12. That's right. What if I have 4 times 3? What do I have? I also have 12. Okay? So this is like check, check, that's good, check, check, that's good. It works. Now, watch this. Subtraction and division are not commutative. So we can't do this, is what it's saying. There is no way to do this with subtraction and division. So check this out. If I have 4 minus 3, I get 1. But if I have 3 minus 4, you're like, I don't even know how to do that. I don't even know what you're talking about right now. Exactly, you can't do that unless you have negative numbers, which we'll be learning in this in the next few lessons. You'll learn that this actually gives you -1. Okay, so these are not commutative. Division, same thing. It probably makes sense to you. 3 divided into 12 gives you 4, but you can't do 12 divided into 3. Okay. The next one is the associative principle. In the associative principle, addition and multiplication, the numbers can be regrouped without changing the answer. In subtraction and division, that does not work. What do I mean by regrouped? Well, let's talk about what grouping is. So if I have 3 plus 4 plus 5. There we go. 3 plus 4 plus 5. Now, I can group these. Okay, I just made a grouping. So I just took 3 and 4 and I put it into a group. You group things with parentheses. Maybe you've seen things like this already. All right. What it says is that I could take this and I could regroup it and get the same answer. So I could say 3 plus 4 plus 5. And now I'm going to regroup it. I'm going to change the grouping, and I'm going to group 4 plus 5. All right, so in order of operation, you always do inside the parentheses first. So watch. 3 plus 4 equals 7. 7 plus 5 equals 12. We can do the same thing over here. Inside the parentheses first, always do that. 3 plus 9, 4 plus 5 is 9. 3 plus 9 is 12. So if you notice, we did it a little bit differently. We ended up with 7 plus 5, but here we ended up with 3 plus 9. Not to worry, because they both give us our answer, which is 12. Okay? So we can regroup. We could also regroup in with multiplication, and it doesn't change the answer. We cannot regroup with subtraction and division. All right, distributive property. This is probably my favorite one. I think you're going to like this. At first, you're going to be like, I don't really need this, but as we get into algebra, you're going to be like, oh, wow, I need this a lot. So for right now, you might think, we'll see. Let's see what you think about it. When multiplying by a sum or difference, the numbers can be multiplied individually without changing their answer. So, what if you have something being, it says a multiplied by a sum or difference? What does that mean? So let's say that I have 5 times 1 plus 2. So what I have is I have multiplying by a sum. I'm multiplying by a sum. Okay? What does it say? It says the numbers can be multiplied individually without changing the answer. So let's do this the traditional style first. Let's do this like we would do this with order of operation. 1 plus 2 is 3. So 5 times 3 is 15. Now, let's do it with this new method. 5 times 1 plus 2. Now we're going to distribute this. What does that mean? That we can do it individually without changing the answer. So check this out. I can take my 5 and I can distribute it. I can multiply it by each one individually. 5 times 1, 5 times 2. All right, so what's 5 times 1? 5 times 1 is 5. Plus, what's 5 times 2? 5 times 2 is 10. Okay? What's 5 plus 10? 15. All right, so again, it looks different. It's a change in how we've been doing things, but we get the same answer. That's the beauty of math. As long as you don't break any mathematical rules, you end up with the same answer. You can do it a little bit different way. There's lots of methods, lots of different ways that we can go about things. So in this traditional method of following order of operation, we did inside the parentheses first, and we got 3. We multiplied 5 times 3, and we got 15. In this new method, we take 5 times 1, and we get 5. We take 5 times 2, and we get 10. We add those together, and we get 15. So just a new way of kind of looking at an old problem, really. All right. So we learned 3 different ways, right? Commutative, associative, and distributive. So now what we're going to do is I'm going to kind of show you something right here, and I want you to try to guess. What is that? What did they do there? So if you see, we have 2 plus 5 on the one side. On the other side, we have 5 plus 2. Okay, what did they do there? They switched the 5 and the 2. What is that called? You remember? That's commutative. Okay, that's commutative. Now, you might say, but I thought that was associative where we switch things. Remember, associative is where we're switching groups of things. So we have to have groupings to do associative. In commutative, we're just switching single numbers. All right, so here's the next one. In this one, we have 6 parenthesis 8 minus 5, close parenthesis, equals 6 times 8 minus 6 times 5. So what do you think is going on there? What did we do there? Yep, that's right. This one is distributive. Okay? This one is distributive. Why? Because what happened? They distributed the 6 times the 8 and the 6 times the 5. There's the 6 times the 8, and there's the 6 times the 5. Notice that this negative sign stays in the same place, right? The negative sign doesn't move. So we don't have commutative there. We're not changing the negative sign. So remember, subtraction and division are not commutative, but in distribution, we can leave them in the same place, and we can make it happen using distribution. So next, last one here that we'll do in this little section is this one down here. Now what's going on here? We took this and we put it in a group, plus 6. Then we took the grouping, basically, and we moved it to the 4 plus 6. Do you remember what it's called when we move groupings, when we change groupings in addition and multiplication? All right, good. It is called the associative. Okay, the associative principle. So make sure that you work on those. Make sure that you know those 3 different principles and how to apply them. Let's just do a couple more practice problems here, and I'll show you why we use them. Why do these make sense? Okay, and you might think, I could do it before. Why do I need to learn these new ways to do it? Well, part of it is that it's going to be shorter. Part of it is that you will actually need it when we get to algebra class. All right, so here we go. We have a problem here, but let me show you something. If we actually do 2 different things here, 2 different properties, principles that we can apply to this, I think you're going to see, oh, wow, that was really easy. So the first thing that I want to do is I want to do a commutative. And what I want to do is I want to say, okay, I want to group 12 and 18 together because those give me 2 and 8 give me 10. Does that make sense? Okay, I'm showing you like a faster way to add. So if we do 12 plus 18, and then if we group them together, because that gives us 2 plus 8 is 10, and then we can know that that's 30 pretty easily, right? So then we take these other 2, and we, using commutative, kind of move them, so plus 27 plus 13. And if we group those together, that gives us what? Well, 7 and 3 is a group of 10. So that gives us 10, carry the 1, that's going to give us 40. Now we can very easily add 30 plus 40. That gives us 70. So if we go back to the original problem, you might have had problem going through this whole thing and getting 70. I did all mental math right there, move some things around. I didn't have to line it up. I didn't have to say 12 plus 27 plus 18 plus 13 and add it all up and do this and carry and do all those other things. So maybe this is just a shortcut for you. All right, and here we have basically a little problem where we have something being multiplied by a fraction. Well, that can be a little bit of a problem. So if you multiply just right straight across, you're going to see that if I try to multiply 2/3 times 8 over 1, I can't really get rid of this fraction. Like I can't reduce this. I can't cross cancel this. So I'm going to get 16 over 3. And then I'm going to have to multiply by a fraction again. So one way that I could kind of simplify this is if I switch the 8 and the 9. Watch what happens. If I switch that 8 and the 9, I have 2/3 times 9. And if I do that, I can cancel 1, cancel 3, and I eliminate my fraction. So now 2 times 3 is 6. So now I don't have 6 over 2, 6 over 3, I just have 6. And then I can multiply times 8 and then times 2. And I can continue on with my process from there. And I might want to even regroup again because look, I don't like 6 times 8. That's not one of my favorites, right? So maybe if I do 6 times 2 times 8, this becomes easier. What's 6 times 2? Well, it's 12. So now I have 12 times 8, and that's one that I don't mind. I like my 12 table, and so now I get 96 as my answer. Okay, so this is just different ways to kind of simplify. Now, notice maybe in this you're like, where's my calculator? I need my calculator right here. No, no, no. You can do this mentally by using these principles to kind of switch things up. So here's the last one. We'll do this one last one, then we'll be done with this video. Here, if you do this first, you're going to get 9 times 7. And again, maybe you don't love 9 times 7. Maybe it's not one of your favorite ones to do. You struggle with the 9's family, possibly, or you struggle with the 7's family in multiplication. Well, you can do this by distributing and go to each one separately. 9 times 2, you know that one, and 9 times 5, you know that one. Those ones are easy ones, so maybe this is just a little bit easier for you. And then you could do this. Obviously, you would get 13 and carry the 1, and you would get 63. And yes, 9 times 7 is also 63. Maybe you knew that. That's easier for you. But I promise you, once we get to algebra, you will find other ways to use the distributive property. I just trying to give you a little bit of an idea there of how you can use it. So that's all I have for you in this lesson. Hopefully you learned something here. If you missed anything, go ahead, slide it back, watch it again. Make sure you know those principles and how to use them. All right? That's all I've got for you. We'll see you later. Have a good one.